Gold bars are among the most valuable objects ever produced by human industry. Compact blocks of refined metal that represent wealth, stability, and trust across global markets. Yet behind every gleaming bar locked inside a vault lies one of the most tightly controlled and technically demanding manufacturing processes in the world. Gold refining and bar production combines extreme heat, chemical separation, precision casting, microscopic purity testing, robotic handling, and security protocols rivaling those of military facilities. What appears to be a simple rectangular bar is actually the final product of a long journey that begins with impure raw gold and ends with a certified asset traded between central banks, bullion dealers, and investors. And today on the How Factory, we're going inside secure vault refineries to see exactly how gold bars are refined, cast, stamped, tested, and sealed under constant surveillance. The journey begins with raw gold feedstock, which rarely arrives in pure form. Gold enters refineries as doré bars from mines, recycled jewelry, electronic waste, industrial scrap, or old bullion melted down for re-refining. Doré bars, semi-refined gold from mining operations, typically contain between 60 and 95% gold, with the remainder made up of silver, copper, zinc, and trace metals. These bars arrive under armed transport and strict documentation. Every shipment is weighed, sampled, logged, and sealed before processing begins. From the moment gold enters the facility, it is tracked continuously through digital inventory systems, cameras, and access-controlled zones. The first major stage is melting. Raw gold material is transferred into high-temperature induction furnaces or gas-fired crucible furnaces capable of reaching temperatures above 1,100 degrees Celsius. Inside ceramic or graphite crucibles, gold melts into a glowing liquid metal. Fluxes, specialized chemical compounds, are added to bind with impurities and separate them from the molten gold. These fluxes help draw unwanted elements to the surface as slag, which can later be removed. During melting, technicians take small samples using vacuum samplers or dip rods. These samples are cooled and sent to on-site laboratories for preliminary analysis to determine the exact composition of the melt. Once melted and homogenized, the gold moves into refining, the step that transforms impure metal into investment-grade bullion. Large refineries typically use either the Miller process, the Wohlwill process, or a combination of both. In the Miller process, chlorine gas is bubbled through molten gold. The chlorine reacts with base metals and silver, forming chlorides that rise to the surface and are skimmed off, leaving behind gold that is typically around 99.5% pure. This method is fast and efficient, making it ideal for bulk processing. However, for gold that must meet the highest purity standards, 99.99% or higher, further refinement is required. That's where the Wohlwill process comes in. In this method, gold is refined using electrolysis. Gold from the Miller process is cast into anodes and placed into electrolyte baths containing hydrochloric acid and gold chloride. When electric current passes through the solution, pure gold dissolves from the anode and deposits onto cathodes as ultra-pure metal. Impurities fall away as sludge, which is later processed separately to recover precious metals like platinum or palladium. This process is slow, energy-intensive, and extremely precise, but it produces gold pure enough for central banks and investment bars. Throughout refining, chemical concentrations, current density, temperature, and deposition rates are monitored constantly by automated systems. After refining, the pure gold is ready to be cast into bars. The molten metal is transferred from furnaces into casting stations located inside reinforced access-restricted rooms. For large bars, such as standard 400-ounce London Good delivery bars, refineries use gravity casting. Molten gold is poured carefully into preheated graphite or cast iron molds. These molds are designed to exact dimensions and are coated to prevent sticking. As the gold cools, it contracts slightly, forming the familiar trapezoidal shape. Cooling rates are carefully controlled to prevent internal stress or cracking. Once solidified, the bars are removed from molds using tongs or robotic arms and placed onto cooling racks. Smaller investment bars, such as 1 kilogram or 1 ounce bars, are often produced using continuous casting or minting methods. In continuous casting, molten gold is poured into long molds and then cut into uniform segments. In minting, refined gold is first cast into flat strips, rolled to precise thickness, and punched into blanks. These blanks are then stamped under enormous hydraulic presses to create perfectly uniform bars with sharp edges and smooth surfaces. Minted bars offer a more polished appearance and tighter weight tolerances, making them popular with retail investors. Once cast or minted, every bar undergoes finishing. Rough edges are ground smooth, surfaces are brushed or polished, and excess material is removed to bring each bar within extremely tight weight tolerances. Even fractions of a gram matter when dealing with precious metals. Bars are weighed repeatedly on calibrated scales, certified to international standards. Any bar outside specification is remelted and recast. Nothing leaves the refinery unless it meets exact dimensional and weight requirements. Next comes assaying, the process of verifying purity. This is one of the most critical steps in gold bar production. Samples are taken from each batch and analyzed using multiple methods. Fire assay, one of the oldest and most accurate techniques, involves melting a sample with lead and fluxes, separating gold from other metals and measuring the result with extraordinary precision. Modern refineries also use X-ray fluorescence spectroscopy and inductively coupled plasma analysis to confirm purity down to parts per million. Results are logged digitally and tied to specific bar serial numbers. If any discrepancy is detected, the entire batch is quarantined for investigation. After purity is confirmed, bars move to stamping and marking. Heavy stamping presses imprint each bar with essential information: refinery name, purity level, weight, year of manufacture, and a unique serial number. For large bars, these markings are often applied while the bar is still warm to ensure deep, permanent impressions. Smaller minted bars may receive laser engraving for cleaner, more precise markings. These identifiers allow each bar to be traced back through the refinery's records, ensuring authenticity and compliance with global bullion standards. At this stage, bars may also receive security features. Some refineries apply micro-engraved marks, holographic seals, or embedded tracking technologies for anti-counterfeiting purposes. These features help protect against fraud in secondary markets. Once marked, bars undergo a final visual inspection to ensure markings are clear, surfaces are free of defects, and edges are intact. The next phase is vaulting. Finished bars are transferred into high-security vault areas within the refinery. These vaults are constructed with reinforced concrete, steel doors, biometric access controls, and round-the-clock surveillance. Bars are stacked on pallets or stored in numbered racks according to customer, batch, or destination. Inventory systems track every movement in real time. Some bars may remain in the vault for years as part of long-term storage agreements, while others are prepared for immediate shipment. Before shipping, bars are sealed and documented. Export bars are packed into tamper-evident containers, often under the supervision of independent auditors. Weight lists, assay certificates, and chain of custody documents accompany every shipment. Armed security teams escort gold shipments to airports, banks, or distribution centers. Even during transport, temperature, shock, and location may be monitored to ensure integrity. Behind all of this is an extraordinary level of security and compliance. Gold refineries operate under strict national and international regulations designed to prevent theft, money laundering, and illicit sourcing. Audits are frequent. Cameras cover nearly every square meter of production space. Access to refining areas is limited and logged. Employees undergo background checks and training. Waste streams, some including slag, dust, and wastewater, are processed to recover any remaining precious metal before disposal. Environmental controls are equally important. Refining gold involves chemicals, high energy use, and metal residues. Modern refineries use closed-loop water systems, advanced filtration, and chemical recovery units to minimize environmental impact. Slag and byproducts are recycled or treated according to strict environmental standards. Even air inside refining rooms is filtered to capture microscopic gold particles. What makes gold bar manufacturing so remarkable is the contrast between scale and precision. These facilities handle tons of molten metal worth billions of dollars. yet measurements are made down to thousandths of a gram. Furnaces roar at extreme temperatures, yet purity is controlled at the atomic level. Security is absolute, but the process must flow continuously and efficiently. Every bar represents not just metal, but trust. Trust in the refinery, in the assay, and in the systems that guarantee authenticity. From impure doré bars to mirror-finished bullion stamped with serial numbers, the journey of a gold bar is a fusion of chemistry, metallurgy, automation, and security engineering. It's a process refined over centuries and perfected with modern technology, ensuring that when a gold bar enters a vault, its value is unquestioned anywhere on Earth. And that is exactly how gold bars are refined, cast, stamped, tested, secured, and stored inside high-security vault factories, a hidden world of extreme precision and control behind one of humanity's most enduring symbols of value. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind the world's most fascinating products.